Hello friends, today we will solve another very popular dynamic programming problem, longest increasing subsequence. This problem can also be found on lead code, and we will solve this problem here. So let's go with the problem statement. Given an integer array nums, return the length of the longest strictly increasing subsequence. Now what is the subsequence? For example, we have got this array 0, 3, 1, 6, 2 to 7, and 3, 6, 2, 7 is given as an example of the subsequence. The most important thing is that the subsequence can be derived from this, but we have to ensure that the order of the remaining elements is still intact. So for example, for this subsequence given here for this array, if I choose, yeah, so 3, 6, 2, 7, right? So suppose I remove 0, 1, and either of these two, then 6, 2, 7 is the subsequence of this array, of the original array. But here in the problem statement, what we want is that it should be strictly into the increasing order. So we can see that 3, 6, 2, 7, this is not in increasing, it's not an increasing order. So what we want to, if I just try to deduce that what can be the solution, so I can just use this, my basic intuition. For example, if I take 0, 3, remove the 6, so I get 0, 3, 6, 7, which is of length 4, and it's in proper increasing subsequence. So this is one of the possible solutions, but I have to check it iteratively for all the possible solutions and find the length of the maximum increasing subsequence. Let's give another try. For example, if I choose another one, say 0, and then I go to 1, and I go to 6 and 7. This is one solution. Again, the length is 4. Or if I choose, say, again 0, 1, I take either of these two. So 0, 1, 2, 7. This is also an increasing order, and the length is 4. So here, this is the way, we have to look for all the possible solutions possible, all the possible increasing subsequence possible, and choose what is the maximum length from which we can find it and return it. Again, let's go to the example here. So in the example, it's the same thing like 10, 9, 2, 5, 3, 7, 1, 0, 1, 18, and the output is given 4, which is that one of the increasing. We need to find all the recursive in the recursive way that what are all the possible subsequences within the increasing order and find the length of the maximum. So this is one of the solutions that I think 2, 3, 7, 1, 0, 1. This is strictly in increasing order, and the length is 4. So let's look for another example. So 0, 1, 0, 3, 2, 3. Again, I can just think about it that its answer you already know that it should be 0, 1. So let me try this. 0, 1. If I remove this 3, okay, so through 3, yeah, 0, 1, 2, 3. That's why the length is 4. We can just check it again. And now here you also see that all the numbers, all the digits in this array is same number. So of course, it can be only like 1 because there is no increasing order here. Longest increasing subsequence has got like it's a very common problem in computer science, and it has got various applications related to mathematics, algorithms, random matrix theory, representation theory, and physics and all. So you can just go on your own if you want to learn more about the application of it, but this is very, very common problem, and there's a very standard approach. It can be solved using dynamic programming approach. Which is what we will see in our next video. So stay tuned.